Yes. Very good afternoon. In this class, we'll be discussing about the 12th lab program of the syllabus, that is on hashing. So fundamentally, what hashing does here is, given a key, a hash function will be applied onto the given key value, and that key value will be mapping to the specified memory address, and the key will be stored on the specified memory address after the hashing function. Basically, hashing function will be applied onto the keys to get the hash key. And the hash key indicates the memory location where the data will be stored. Now that hashing part we are trying to implement in this program. We have to create a file containing n employee records. In this case, we are assuming that file as the table itself. That is our hash table with set of k keys which are 4-digit in length. That is, key values what we are giving are 4-digit in length, which are uniquely determining the records in the file. Now assume that the file F is maintained in the memory of hash table. That means we are assuming the file. Our file is maintained in the hash table of M memory locations with L as set as the memory addresses of 2-digit. See, keys are of 4-digit and memory addresses are of 2-digit length. And they are going to occupy the locations in the hash table. Now let the keys in the K and addresses in the L are integers. So K indicates the addresses and L indicates the K indicates the keys and L indicates the addresses. So we need to develop a program by applying the hash function, that is hash. This must be arrow mark like this, right? Hash function applied onto the key to generate L memory locations. That is nothing but, here specifically we are going to consider the remainder method, h of k equal to k mod m. That means onto the given key, divide it by the m. That is, m indicates memory locations, and whatever remainder you get, that will be the outcome of the hash function. And implement the hashing technique to map the given keys to L memory addresses. And in case if you get any collision, that must be resolved by using linear probing. So what is collision? If more than one keys are mapping to the same address, that is called as collision. And that will be resolved by using linear probing. So what is collision and what is linear probing, that also we have seen in theoretical classes. Once again, I will be addressing that here with practical example. Now let us consider the size of hash table has 10. That means it has addresses from 0 to 9. That's assumption we're going to do. And these are the prototypes of the functions what we use. One for storing, another one for displaying the contents of the hash table. And HT is our hash table, which can hold up to 100 elements. So we'll start with the main function. Declare these local variables. Key indicates the normal key what we give as the input, and HK indicates the hash key. Keys are of length 4-digit and HK is of length 2-digit. Right, and these are the other local variables. And in the beginning there are no elements in the hash table. That means for every value of m, I am going to store -1 in the beginning. For every iteration of the for loop, onto the ith location of the hash table, store -1. So that is how it looks. In the beginning, everywhere it is -1. That means I'll try to show you the output how it is here. This is what is the content of the hash table. The beginning hash table, what we have done, we have just tried to display here that the every location 0 to 9 -1 is stored in the beginning, because there are no elements in the hash table. In the beginning, hash table is empty, and that is indicated by storing -1. Now provide these options for the user. What you want to do? You want to insert key, you want to display, or you want to exit. That choice will be stored here. And let us first go for choice 1, inserting keys onto the hash table. So before that, I'll consider the sample input. The sample input what we provide to our hash table, that is sample input. These are the numbers what we give now. That is 1005, comma 2009, then 4857, 2344, 7676, any numbers you can assume. Just to satisfy all the conditions, I have selected these numbers. 2005, then later 2008, 4973, 5342, 6453, then 2345. This is what is the input for our program. These are the keys, given 4-digit keys. As you can see here, all the keys are having a length of 4 digits, 4-digit keys. Now that's why we are scanning them in the width of 4 digits, and they will be stored in the variable called key. And now that key must be stored onto the hash table. But before we store, what is the hash function? Hash function here is the remainder method. We are going to make use of remainder method to generate the hash values. So how do you generate the remainder method? The hash key is given by the given key modulo m. The hash key is given by the given key modulo m. Hash key is given by given key modulo m, and that hash key will be stored onto the hash table. So for example, this line I will explain. Given key modulo m, what happens? For example, if the key is, what is the first number? First key is 1005. And what is our hash function? Given key modulo m. So hk is given by the given key modulo m. Modulo m means it will return the remainder. So what is the given key? 1005. 1005 modulo m. What is m? M is 10. M is 10. See here, we have declared here in the beginning. M is 10. Okay. So when I consider this, what result will get? We'll get result as 5. And this is what is our hash key. This is what is our hash key. So how you got 5? I think I need not explain you. Modulo. When you divide it by modulo, you will get what? 10 into 100. You will get 1000. And what is the remainder? The remainder is 5. This is what is the hash key. This is what is the hash key, normal division. That means for the first key, what is the hash key? Hash key is 5. That means in the hash table, 1005 will be stored in the 5th location. In the hash table, 1005 will be stored in the 5th location. So let us call the store function. Let us see where it will get stored. What is the key value now? Key value is 1005. What is here? Key value is 1005. What is the hash key? Hash key is 5. So both we are passing to store function. So key is 1005. Hash key is only 5. How we have got 5, that already I have explained. Let us go to the definition of store function. This is where is the store function. What I will do here is I'll just copy this store function to this blackboard so that explanation will be easier. Explanation part will be easier. I hope this font size is visible to you. I'll still try to increase the size. Yes. Okay. I'll take the and what is key value here? I need to change the color now. I'll take this red color. What is the key value here? Key is 1005. What is hash key? Hash key is 5, and that must be stored in the hash table. What is our hash table in the beginning? We know that 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is what is our hash table. -1, -1, -1. Everywhere -1 is stored in the beginning, which we already saw. In the hash table, everywhere -1 is stored. right? This is what is our hash table. This is what is our hash table, HT, hash table. Now where this 1005 should be stored? 1005 should be stored in the location number 5. If it is empty, it will get stored here. Then we'll start with the position as -1 and then flag as 0. Now if hash table of HK is it -1, check, because you should, before you store 1005 in the location 5, you should check whether it is empty. If it is empty, it will be empty only when -1 is there. What is HT of HK? HK is what? HK is 5. So what is hash table of 5? Is it equal to -1? True or false? Yes, hash table of 5 is -1. Hash table of 5, fifth location is what? -1. It is true. In that case, what we do? In that location, hash table of 5, we are going to store the key value. We are going to store the key value. In that fifth location, we store the key value. In that fifth location, we store the key value. So I'll erase this and I'll store the key value in the fifth location. What is the key value? 1005. 1005 is successfully stored, right? And it will simply return. It will simply return to the column. So where it will return? It will go back to again the main function. It will go back to again the main function. Again you will be giving choice 1. And again you perform the hash key. These two I will go on explaining now. You will give choice 1 for inserting, because that is the only case we have to go on inserting and we have to go on displaying. Next key you take, divide it by m, then obtain the hash key, then again call the store function. These two lines are only essential in this case. So these two lines I will explain here itself. So what happens? What is the next input? What is the next input? After 1005, here I have written those numbers. This is already stored. What is the next number? Next number is 2009. So now you substitute this here. 2009. 2009 modulo 10. What result will get? Can someone tell the answer? 2009 modulo 10. What is the hash key? First. 2009 modulo 10. What is the remainder? What is the remainder? I am asking to you. When you divide 2009 by 10, what is the remainder that you get? Very simple, right? Into 200, it is 2000, remainder is 9. So this 9 is our hash key.
9.
Yes, 9 is our hash key. 9 is our hash key. That means what it indicates, next number 2009 must be stored in the location 9. So I'll go to that part, storage part. Now let us go to storage where 2009. What is the hash key that you have obtained? Hash key we have obtained is 9. What is the key? Key is 2009. Key is 2009 and hash key is 9. So let us go to the function. What is the key here? I'll erase this. What is the next key? Key is 2009 and what is the hash key? Hash key is 9. What it indicates here is 2009 must be stored in the location number 9. 2009 must be stored in the location number 9. Check whether that hash key of 9, hash table of 9, is it -1? Ninth location is -1, that is 3. That means I can store that. Take the key and store in that location. What is the key? 2009. Store in the 9th location. Store in the 9th location. So it will get stored in the 9th location. 2009 is successfully stored. Return. Simply we will return back to the caller. Simply we will return back to the caller. Right. So where it will return? It will again go back to the main function. This location itself. Again the choices will be displayed to the user. Say again you have given choice 1. Then the key will be read. What is the next key? Next key is 4857. So these numbers I will be not telling again and again. Then I will be taking one number at a time from now onwards. So 4857 is the next key value. So read that. 4857 will be read and we are going to obtain the hash key. From the 4857 obtain the hash key. What is the hash key now for 4857? Can someone tell? What is the key? Key is next key, this one. Next key is 4857 modulo 10. What is the hash key?
7, sir.
Yes, hash key. Simply it's a reminder method. Hash key is 7. That is what is hash key. Because if you go on dividing by 10, whatever unit digit is, that is the hash key. That is understood. Whatever unit digit is, that is hash key. Here hash key is 6, hash key is 5, hash key is 8, hash key is 3, hash key is 2, hash key is 3, and hash key is 5. That is well understood and well known simple mathematics. And what is the key in this case? Key is, what is key? Key is 4857. And what is hash key? Hash key is 7. Let us go to store function. What is key? Key is 4857 and hash key is 7. Check the condition. Is hash in the hash table, the 7th position, is it -1? HT of 7, is it -1? HT of 7 is -1. It is empty. That means I can store there. Take the key 4857 and store it in the 7th location in the hash table. So this is what is 7th location. What I'll do, I'll erase the 7th location. Then I will store the key. What is key? 4857. 4857. 4857 is stored here. Next, simply return to the caller. Again, we'll go to the main function. Again, we'll display the options. Then ask for the user to enter the key. So in this case, what is the next key? Next key is what? 2344. Next key is 2344. Next number 2344. Then what hash key we get? For 2344, hash key is 4. Then try to store these numbers. This function will be called again from there. So what is the key value now? Key value is here 2344. What is hash key? Hash key is 4. Now again try to store that into the memory. Hash table of 4th location, is it -1? Yes, 4th location is -1. That means I can store there. Simply take the key and store it in the 4th location. What is key? 2344. In the 4th location, 2344 will be stored. I'll erase this and I'll go to 4th location and store what? 2344. 2344 is stored. Again return to the caller and take the next number. Return to the caller and take the next number and find the hash key. So what is the next number now? Next number is 7676. Assume next number is 7676. What is the hash key that we get? Hash key, when you divide 7676 modulo 10, hash key is 6. Now this function will be called again. What is the key? 7676 is the key. And what is the hash key? Hash key is 6. Now that, check the 6th location. Hash table of 6th location, is it -1? 6th location is -1. That means the key will be stored in the 6th location. Key will be stored in the 6th location. I'll erase the 6th location and key will be stored. What is that key? 7676. This is how the hash table gets created. Okay. Now I'll erase this and go for next key. Let us go for next key. After 7676, next key is 2005. If you take 2005, what will be the hash key for this? HK will get it as 5. Again call this function, store function, by giving key as 2005 and hash key as 5. Assume these positions as -1 and flag as 0 as well, it will be there. These two will be set. Now hash table of 5th location, is it -1? Is it empty? If you can see here hash table, the 5th location is already occupied and this is what is called as collision. Already there is one element and we are trying to store one more element called 2005 in the 5th location. This is going to cause collision. And how to resolve this collision? We have to go for linear probing. What happens in the linear probing? Just immediately check the next location, 6th location. Is it empty? No. If it is not empty, just immediately check the next location. If it is not empty, immediately check the next location. So till you get the next location, you have to go on checking. Then here is the 8th location. This is where it is free and we are going to store the number. So let us see the coding part for that. Right? linear probing, how the next location is found. For value of I equal to, that means we should find the 8th location. We should check what is hash key here. Hash key is 5. 5 plus 1 is what? 6. That means we will start from the 6th location onwards. That means we have encountered collision here in the 5th location, and you should start searching from the 6th location onwards for the free location. Start from 6, 7, 8, 9 onwards. And is that I is less than M? So M is what? 10. I is what? 6. 6 is less than 10. Condition is true. Go on checking the free location now. Now hash table of I is 6. Hash table of 6 is the 6th location is empty. Hash table of 6, it is not empty. That means I will skip this part and we will go for incrementing the value of I. I becomes 7 now. I becomes, earlier I was 6. Now I becomes 7. 7 is less than 10. Condition is true. Check the condition. Hash table of 7th. The 7th location in the hash table, is it minus 1? 7th location in the hash table, is it minus 1? No, it is false. That means we will not enter into this. What I will do? We will increment the value of I. Now I becomes 8. 8 is less than 10. Condition is true. Condition is true. Return the for loop. Check the 8th location now. Hash table of 8th location. Is it minus 1? Hash table of 8th location. Is it minus 1? Hash table of 8th location. Is it minus 1? Yes, it is minus 1. That means you can save the number here. Which number? 2005 can be stored here. That means position we have obtained. Which position? Position is 8, because value of I is 8 and flag equal to 1. What flag equal to 1 indicates? We have found the location. We have found the location for 2005. Then simply break it. Then simply break it. There are two possibilities. Either you have found the position or you have not found the position. In this case, if the flag is 0, that means we have not, if we have not found any position here, then we may found position from the beginning of the hash table. That we shall see later. Now, is flag is equal to 0? No, it's not the case. That means if flag is 0 after doing all these things, then it is hash table. Else what we do? At the specified position in the hash table, store the key. At the specified position, what is the position that we have got? We have got position as 8 now. Here we have got position as 8, and in that 8th location we are trying to store the key. What is key you are trying to save? We are trying to store key 2005. See here, the next element is 2005. So where 2005 will get stored now? 2005 will get stored in the position 8 in the hash table. So in the 8th position of the hash table, 2005 will get stored. 2005 will get stored. Now all the locations are full here, and here are the locations which are empty. Here from 0 onwards the locations are empty. Let us see how it happens. Let us take the next number, so which will be interesting one. Right? I'll erase these parts. I'll erase everything whatever we took for explanation. Right? So let us take next number. After 2005, next number is 2008. Let's take next number. Next number is 2008. For 2008, what is the hash key? Hash key is 8, which is understood. Now again call the store function. 2008 hash key is 8. Position minus 1, 0. Then check in the hash table 8th location. Is it minus 1? Is it empty? No. See here, 8th location is already occupied. That means once again we have got the collision, and you have to go for linear probing. What happens in linear probing? Start from the next location onwards. Search the next location onwards. Right? So let us perform. See here. Here in this case, next location is also empty. That means we will come back to the hash table and store it here in the beginning. 2008 will get stored here in the 0th location because it is empty. Once it is empty, you go back and search from the beginning. Now search for location. What is hash key? Hash key is 8. 8 plus 1 is what? 9. So 9 is less than 10. Condition is true. Hash table of 9th location, is it minus 1? Hash table of 9th location, is it minus 1? I is 9 here. See? I is 9. So the hash table of 9th location, is it minus 1? No, it is not minus 1. That means it is also occupied. Once again, we have got the collision. That means the hash table is full here. See here. Once you next, if it is collision, we will go for incrementing the value of I. Now I becomes 10. 10 is less than 10, condition fails. That means we will come out of the for loop. We will come out of the for loop. That means flag is 0 only. The position is not found. Search from the beginning of the hash table. Look at the comment here for understanding purpose. If position is not found, search from the beginning of the hash table. See here we don't have any position here at the end. Then we will come back and search from the beginning of the hash table. Search again from the beginning of the hash table. That means beginning means you have to start from the 0th location. What is the code for that? If flag equals 0, what we do? We start from 0th location. Start from 0th location and till it is less than hash key. So what is the hash key we have got here? Hash key we have got it as 8. That means start from 0 and go up to 7th location. Check whether hash table of 0 is it minus 1. 0th location is it empty? Check the hash table. Hash table 0th location it is minus 1. That means it is empty. You can save 2008 in this location. Right? So what is the position that we have got now? Position equal to I. What is I? I is 0. I is 0. And flag equal to 1. 1 indicates we have found the location. Then finally come for this if statement. Check this if statement. If flag equal to 0, it will be 0 only when we have the overflow. All the locations are full. In this case, locations are not full. Then go to else part, where the key will be stored. Which is the key that we are referring now? 1 second. Key is 2008. So 2008 we are trying to store. 2008, where it will get stored? It will get stored in the hash table of which location? What is the position that we have got? Position we have got as 0. So that means hash table of 0th position store the key 2008. So where 2008 will get stored? 2008 will get stored in the 0th location. I'll erase this and I'll store 2008 here. 2008. So this number is successfully saved now. I'll erase this part. What is the next key? So next key is 4973. 4973. So what is the hash key for this? Hash key for this we'll get it as 3. Where it will get stored? Can someone tell the answer now after so many iterations? Key is 4973. Hash key is 3. Where 4973 will get stored? Where 4973 will get stored? Anyone unmute yourself and tell where 4973 will get stored. See, hash key means very simple, right? Third location. It will check third location, is it empty? If it is empty, if it is minus 1, it will get stored in that location, right? What is the key? 4973 is the key. Key is 4973. What is the hash key? Hash key is 3. Check. In the hash table, third location, is it minus 1? In the hash table, third location is minus 1. That means simply save the key in that location. Key 4973 will be stored in the hash table. (4973) will be stored in the hash table. Simply return to the caller and get the next number. Then get the next number. So what is the next number after 4973? 5342. So 5342 is the next number. What is the hash key for this? Hash key for this is 2. Call this function once again with these numbers, right? With these numbers, what are those numbers? 5342. And what is hash key? Hash key is 2. Position equal to minus 1, flag equal to 0 in the beginning. In the hash table, second location. Check the second location because hash key is 2. In the hash table, check the second location. Is it -1? In the hash table, second location is -1. It is true. That means key will be stored in the second location. What is that key? 5342 will be stored in the location 2. 5342 will be stored in location 2, and simply return to the caller and scan the next number. Scan the next number. So what is the next number? 6453 is the next number, and for this hash key we will get it as 3. Call the function again. Call the function again with these numbers. Call the function again, that is 6453 is the key and hash key is 3. Check in the hash table, third location, is it -1? Third location is -1. It is not -1, it is occupied, and we have got the collision here. Once you get the collision, you have to perform linear probing. Check the fourth location, is it empty? Check the fifth location, is it empty? 6, 7, 8, 9. Again come back to 0, then 1. So it will get stored here. Let us see the tracing part for that. Let us perform the linear probing now. Linear probing. Right? So what is the hash key? Hash key of what is that? 3. 3 plus 1 is what? 4. What is the value of I? I is 4. I is less than 10. That means from fourth location, when 3 is full, here, when 3 is occupied, if from fourth location onwards, you have to search for the free location. I is 4. Hash table of 4, is it -1? No. See, hash table of 4 is also not -1. No. Then increment the value of I becomes 5. Check. Hash table of 5, is it -1? No. See, hash table of 5 is also not empty. Increment the value of I, 6. Hash table of 6, is it -1? It is also not -1. Increment the value of I. Hash table of 7th location, is it -1? No. Increment the value of I becomes 8. Hash table of 8, is it -1? No. Then increment I becomes 9. Hash table of 9, is it -1? No. Then we increment I, it becomes 10, and finally we'll come out of this for loop. We'll come out of this for loop. That means from this third location onwards, from fourth location onwards, there is no free location at the end of the hash table. Now we have to come back and search from the beginning. We have to come back here and search from the beginning. That is the other part. That means if position is not found, search from beginning of the hash table. That is flag equal to 0. What it indicates? Position is not found. Start from the first location. Right? Start from I equal to 0. Then what is hash key? Here. Hash key we have got it as 3. Hash key is 3. Till you are less than 3, check the condition. In the hash table, 0th location, is it -1? In the hash table, 0th location, is it -1? No, it is also occupied. That means go for incrementing the value of I becomes 1. Again check this condition. In the hash table, value of I is what now? Value of I is 1. In the hash table, value of I is 1. Hash table of 1. Is it -1? Check the hash table. Hash table of 1. Is it -1? Yes, it is true. That means we have found the position for that. What is position now? Position is I. Position is I. What is value of I? I is 1. That means in the first location we can store the number. In the first location number 1 we can store the number, and flag is 1. Ultimately if the flag is 0, it is overflow. Now in our case flag is 1 here. That means we can store that number. We can store that number. Which number we are trying to store? 6453. 6453. Key is what? 6453. Where it will get stored? In the position number 1. Because here after traversing we have got position as 1. So hash table, the first location of hash table, store the key 6453. It will get stored here in the first location 6453. The first location, what will get stored? 6453 will get stored. Now all the locations are full. Now if you read the next number, we'll get the overflow. If you read the next number, we will get the overflow. So let us take one more sample number now, just to demonstrate the overflow. Let us take 2, 3, 4, 5. I will take one more number 2, 3, 4 because hash table is full now. We cannot save any numbers. What is the hash key for this? Hash key for this is 5. So check the fifth location. Hash table of hash key. See here, number key is 2, 3, 4, 5 and hash key is 5. In the fifth location, check. Hash key of hash table of fifth location, is it -1? Fifth location, is it -1? No, it is occupied. That means we have got the collision. Now you have to perform linear probing. Check the next locations. Perform linear probing. So what is hash key now? Check everywhere, all the locations. Hash key is what? Hash key is 5. 5 plus 1 is what? 6. That means I will start from 6th location. We'll start searching from the 6th location onwards. Is hash 6th location in the hash table, is it -1? 6th location in the hash table, is it -1? No. That means increment the value of I. Increment the value of I becomes 7. 7th location in the hash table, is it -1? No. Increment the value of I becomes 8. 8th location in the hash table, HT of 8, is it -1? No. Increment the value of I. Then check the 9th location, hash table of 9. 9th location in the hash table, is it -1? No. Increment the value of I. I becomes 10 and we will come out of this for loop. That means at the end of the at this side we don't have any position for the number. Now you have to come back and search from the beginning. Position is 0. Now I will start searching from the beginning of the hash table. We'll start searching from the beginning of the hash table. Beginning in the sense we have to start from 0 onwards. Start from I equal to 0. I equal to 0 until less than hash key. What is hash key? Hash key is 5. What we have got here? Hash key is 5. Starting from 0. Is the 0th location is -1 in the hash table? See here, all the locations are occupied. 0, 1, 2, 3, 4 all are occupied. Up to 4 it will go on checking. Is 0th location is empty? No. Is first location is empty? No. Second location? No. Third location? No. Fourth location? No. That means from the beginning also there is no space. From beginning also there is no space for the number 2, 3, 4, 5. From the beginning also there is no space for the number 2, 3, 4, 5. That means what? The flag remains 0 only. Flag will not get changed. And once flag is 0 only, what we get? We get the message as hash table overflow. We get the message as hash table overflow. So this is how the hash table gets created by using hash function. So that was the very first part, storing. Then display function. Display is very simple. It will just display in the form of 2 dimension. It will display in the form of matrix. How the display function works here is display function hash table will be printed as it is starting from 0 up to m. That means repeat the loop 10 times 0 to 9. And in the space provided by 2 column, what you do, give the value of I, then hash tables entry. That is I will range from 0 to 9 and hash table of I. This table will be printed as it is. Not here. This table will be printed as it is. This will indicate I and this is h of I, h of I, h of I. So the display function will work in a simple manner. This is just a comment, just ignore this. This is how the display function works. So both the functionalities we have seen. So this is one sample input what we have demonstrated, what we have seen, collision and all. So what I will do, if possible, I'll try to demonstrate the execution part for the hashing. The simple technique here is take the key, divide it by 10 and obtain the remainder value. And whatever remainder you get, that will be the hash key. And in that location, in the obtained remainder location, we have to store the element. We have to store the element. And in case if more than one element is mapping to the same location, then search the hash table from next location onwards. That is called as linear probing. And in case if you don't get any location from the next location till the end of the hash table, reverse back, come back and search from beginning of the hash table. Search from beginning of the hash table. Then if you find any locations there we will store the element. After trying from the beginning also, if you don't get any locations for the element, then it is called as hash table overflow. So this is what is a simple technique. Now I will show the demonstration. I will show the demonstration for the 12th lab program with the same numbers, whatever we took just now for the explanation purpose. Right? So these are the different choices. I'll give choice 1. So before the choice 1, I'll just display the empty hash table so that you can understand. I'll give choice 2 for display. You can see here, this is the empty hash table. All the locations are -1. I'll give choice 1 and I'll give the key. What was the first key? 1005 is the first key. I'll just try to display it and show you. See here. 1005 is stored in the 5th location. Again, I'll give choice 1. So enter the key. 2009 is the next key. Again, I'll give choice 1. 4857. 4857 is the next number. I'll give display and show you. Yes, 3 numbers are stored here. 4857 is stored in 7th location. 2009 is stored in 9th location. 1005 in 5th location. Again, I'll give choice 1. Next number 2344. Again, choice 1. Next number 7676. 7676. Right. Before I give next number, I'll display it once. Yes, what are the numbers now? These are the numbers which are displayed. If I give choice 1, and number as 2005, where it will get stored? Can anyone tell now? Can anyone respond where 2005 will get stored in the hash table?
Location
Yes?
8.
Location? Yes,
8.
it will get stored in the 8th location. Why? Because the 5th location is already occupied. By using linear probing, it will go for the 8th free location. So let us see whether it is stored or not. I'll give choice 2. Yes. You can see here 2005 is stored in the 8th location. Let us view next number. Choice as 1. Next number is 2008. Where 2008 will get stored now? Because there is 8th space is occupied. 9th space is also occupied. Where 2008 will get stored? Yes, any answers? Where 2008 will get stored?
In 0 location.
Yes, it will get stored in the location 0 because once the hash table is full at the end, we'll come back and search from the beginning. So let us display it. Yes, you can see here it is stored in the location 0. Next, I'll give one more choice. Then 4973, 4973, enter. Again one more choice. 5342, 5342. One more choice. 6453, 6453, enter. Now say display. Our hash table is completely full now. There are no elements which can occupy the no elements can occupy the hash table now because hash table is completely occupied. Now let us give one more choice to check hash table. I'll give insert again. I'll give some number called 2345. Enter. We will get error saying that hash table overflow. We cannot insert the elements. And last choice is 3 for exit. This was the explanation and demonstration for the hashing program. That is 12th lab program on hashing. If you have any queries, you can ask. Please.